In two different situations. One is when current flows in a straight wire, then around the straight wire current, the circular magnetic field lines are formed. You apply right hand grip rule. Along the current, you know that you put your thumb of your right hand, as you can see. This is the wire in which current is going upward. You have to put your thumb along the current and then you will curl your fingers. This curling of your fingers, it will show the direction of circular magnetic field lines around the straight wire. If current is going upward, then there will be anti-clockwise magnetic field lines. This thing you can apply with this right hand grip rule. And if current will come downward, then field lines will be in clockwise order. Then also there is one other important case. If current is flowing in a solenoid which is a coil. In this coil, when current is going, then definitely around the solenoid we get magnetic poles. On one side we get north pole, on the other side we get south pole. For this purpose, in order to find the poles, we apply right hand grip rule again. This is a very important area, students. Right hand grip rule is applied in two different situations. One situation is there is a wire in which current is going upward. Straight wire, current is going upward or downward. Then in case of this straight wire, you put thumb along the current and curling of your fingers will show the direction of circular magnetic field lines produced around the current. This is the one situation. And other situation is to find the magnetic poles due to current flowing in a solenoid. In this case, the rule you will apply in a different way. Along the rotation of the current, you will put fingers of your right hand. Along the rotation of current, you will set fingers of your right hand and will check the position of thumb. The thumb will show north pole of the magnetic field and other side will be the south pole. This thing definitely in electricity, when I will go, we have to get reference with these rules. Then furthermore, there are two important rules in your electricity. Fleming left hand rule and Fleming right hand rule. Mostly I observe that students are confused where left hand rule should be applied, where Fleming right hand rule should be applied. So it is very clearly given in case of DC motor. You know that the motor is a device which converts electrical energy into mechanical energy. Mechanical energy means when you will switch on the motor, you will supply current, and around the current carrying coil, a magnet is present. And due to this current flowing in the coil and due to the presence of this magnet, as you can see in the diagram, the rotation is produced. This direction of rotation, direction of motion, or this is called direction of magnetic force. This thing you can find with Fleming left hand rule. This Fleming left hand rule is applied in DC motor. In DC motor, the direction of current will be given to you, and also direction of the magnetic field is given to you. Magnetic field is always pointed from north pole towards south pole. So these are the fingers position. This index finger, it represents magnetic field. This second finger, it represents direction of current, which is the conventional current along the flow of positive charges. And the position of thumb, that shows direction of magnetic force or direction of motion of the wire. So Fleming left hand rule we will apply in DC motor. Definitely when I will go in DC motor, I will utilize this rule. Just for introduction, I'm telling you, okay, these four rules I have summed up at one page. Then there is a Fleming right hand rule. This Fleming right hand rule is applied in AC generator, alternating current generator. In current generator, you know that what happens? Okay, magnet is present and there is a coil. This coil, this wire you have to move. You will move this wire in between the magnetic field, and there will be change of magnetic flux. You know that about generator. Later on, I will discuss its diagram of generator with you. In generator, we have a coil. We will rotate the coil between the magnetic field, and due to this rotation of the coil, the magnetic field lines cut to the coil. This is called change of flux. Because of this change of flux, alternating current and EMF is induced. EMF, this term, electromotive force. This is the basically electrical energy, total voltage. This voltage or current, when it will generate, it will induce you have to find direction of this induced current. So for this purpose, in order to find the direction of induced current in AC generator, we apply Fleming right hand rule. Fleming right hand rule, you will have a coil, rotation you have to supply, magnetic field will be there around the coil, and as a result, current will induce. This direction of induced current will be unknown, which we will find with Fleming right hand rule. So these are the basic rules basically. Just I want to tell you these force rules I have added at one place. This is the Fleming right hand rule. Sorry, this is the right hand grip rule for a straight wire. This is the right hand grip rule for a solenoid.